Here we go. TrigApps 1b, unit vectors and direction angles. Here's a unit vector, vector v. Here's another one, vector u. Not you, but you. He's a unit vector, vector z. Sector, vector, kind of funny. And this is a unit vector as well. For lack of better choices for letters, I chose w. Now, if you take a bunch of these unit vectors together, it creates a unit circle. I can replace this v or u or z or w with an r, meaning the radius, and it would make a lot of sense for students who have studied trig, or an h for hypotenuse of a triangle. And notice that I put this little tick mark here to communicate to you that if this is one unit, and I'm creating this 45, 45, 90 triangle, I have to take this root 2 side and divide by root 2 to get to the height or the adjacent side. So that value is 1 over root 2 and 1 over root 2 there. All right, let's get into it. The first thing is unit vectors in general. As I basically just showed you, a vector is a unit vector if the magnitude is 1. That's all that notation is saying right there, is the magnitude of u. How intense is that vector? So really one of the main things that we're going to try to do is create a unit vector based on a vector that's given to us. Whether that vector is 2 units long or 5 or 4.7 or 7.9. So here's the notation for a unit vector. If we take that unit vector u and divide it by its magnitude, we get a unit vector in the direction of u. And when we do that, that result will be in component form. We'll cover one of those examples in just a moment. That's it for unit vectors. Let's talk about a standard unit vector. Basically, if we write a vector in component form, that's exactly what it is. But we could also write vectors in standard form, which is just another way to write it, and it's a little bit more convenient for, say, writing it in a paper or describing it in a science journal or something. There are 2 standard unit vectors. The first one is called I. Yes, I know. I is the imaginary unit that's used for other things. This is not that I. And usually, by the way, this I would be bolded. If you look at textbooks, it would be a bold I. And then j is the other unit vector. I is a special unit vector that just goes to the right 1 unit. If we have a starting point, it's just moving that point to the right. And then for j, all it's doing is moving up 1 unit. Think about this. If we're moving to the right 1 unit, that's 1 unit. That's a unit vector. And if we're moving up 1 unit, that is showing a vector that has 1 unit as well. Okay, now if we have any random vector, call it v, and it's in component form, a comma b, a could be 2, b could be -3, doesn't matter, and we'll do an example on the next page as well. But any component form vector could be written in standard form like so, ai plus bj. Specifically, what that means is we're going a units to the right, so using that I component. So I is related to the x component. And then we're going b units up. And that could be a whole number, a negative number, a decimal, whatever. But basically, I just want to point out, some students wrestle with this or struggle with it. Really, all this is a different way to write the component form without notation. You know what I mean? Without that component form, which, by the way, is annoying sometimes. Okay, so let's do an example. The example that we have here is finding a unit vector in the direction of this vector 2, -3. The first thing that we'll do is just verify it that it's not a unit vector. Take both of those components, square them, and we get the square root of 4 plus 9, which is equal to the square root of 13, which we know is not 1, but just to kind of check, I put this in the calculator and it gave me something like 3.6. That is clearly not a unit. 3.6 is 3 units and some more. So what we'll do is we'll take that formula that we had, that simple expression there, v divided by magnitude of v, And we'll write that component form, that 2, -3, divided by the root 13 that we just found. I'm realizing that we didn't just find that root 13 just to know that it's not a unit, but we're going to use that in the formula anyway, so we might as well calculate it first and to think about what that number is. Now, really, this is the correct answer, I guess. It's just not really in a sensible format. We'll use the idea of scalar multiplication or division with that root 13 and basically divide the 2 by root 13 and the -3 to get this component form of the vector. Now, this is in component forms. We're going to write it in standard form, so hopefully you have some more space to write this. But, you know, sometimes it's best to write it in a rationalized form. That may not always be the case with some of the questions that you practice. If they have them in a different form, okay, fine. You know, it's not a huge deal. Especially because we're in an applications unit, many times we'll actually go down to a decimal anyways. Once again, that is in component form. Now we'll convert that to standard form, saying, all right, I have a 2 root 13 over 13 in the direction of x, moving to the right. You know, so I'll take that 2 root 13 and multiply it by I to give us just the x component. That's the AI, and then plus a bj, and I'm noticing that it's negative, so -3 root 13 over 13j, and that's in standard form. Oops, oh my goodness, not a -3 there. So I could say plus, I could say plus a -3 root 13, or just say minus. All right, and that is just finding a unit vector in component form and standard form. I feel like the rest of the stuff that we're going to talk about is pretty intuitive, so I hope that is indeed the case for you. Vector v with direction angle 120 and magnitude 8. The first thing I like to do with a question like this is to just give it a quick sketch. And we have this angle 120, which means that we have a 30, 60, 90 triangle. I don't know. How am I going to do this? This is pretty good, I think. Means that central angle is 120 degrees. That means this inside is 60 degrees. Which reminds me, by the way, that again, and also in TrigApps, many of the uses of angles is going to be in degree mode. So there's a 30 degree there. That 8 is basically going right there. That's the magnitude. All right, that means now we can actually solve this whole thing, create this vector. Basically, how many units are we going to the left and how many units are we going up, just by using trig, basic trig. And that means cosine 60 equals x over 8. Cosine 60 is adjacent over hypotenuse. And if we solve that in the calculator, you know, punching in cosine 60 is going to give us 1/2. But when we look at our picture, we notice that that 1/2 is to the left. So it's a negative 1/2. So that 4 is basically a negative 4. And what I would do to write that is I would say, all right, we're in quadrant 2, so negative 4. Okay, and then I'll just kind of separate that with my y value stuff for y. Now at this point, I mean, really I could say, because that value is 4, this is a 4 root 3, but I'll set it up anyways. So sine 60 equals y over 8, and that means that we're taking sine of 60, which is root 3 over 2. And so that indeed is 4 root 3. Still didn't really answer the question. What's the vector v with that direction, angle, and magnitude? Well, the vector v is equal to the component form -4 comma 4 root 3. Now let's double check that we make sure that we know what's actually going on there. That -4 4 root 3 means we're starting at the origin, we're moving -4 units, and we're going up 4 root 3 units. Hopefully that's a happy place for most of you at this point, just working with cosine and sine. Last thought for this lesson, which is fairly short. We are just finding the direction angle of a vector. And we kind of need to know basically where those vectors are, what the component form of the vector is, so that we can sketch them and understand what the movement is. I'll just take u and I'll plot u, -2 comma 3. And I'll plot v, -4, -1. And you could plot this in your space as well, but not hugely important at this point. All right, let's think about this for a moment. Now, if I drop an altitude for u, what I'm basically trying to find is this angle. So if we know the angle inside, then that could help us find the direction angle. And the best approach that we could use for that is tangent theta equals 3 over -2. Opposite over adjacent. Okay, now I'm going to go to the graphing calculator in degree mode, and you're going to see kind of an issue pop up. So if I type second tangent 3 over -2, I get -56.31 basically. All right. And when I look at my picture, I'm like, what the heck is that? That's not that angle inside there. Okay, what that is tangent. It's based on the domain of arctangent. And what that is the angle that's down here, which I don't know if you could see it, but that's basically creating this line right here. So all we need to do is add 180 degrees to that number to get the question mark. Okay, so that is the actual answer to the question. Another way to look at it is that -56, I think that might even be that angle inside there, but it's not just turning it into a positive number. That's not what's solving the issue. All right, let's take a look at v. V is a little bit easier because I think it gives us exactly what we want. So let's just call this theta or alpha, and we're going to do -1 over -4. And by doing that, we get alpha equals 14 degrees. And in this case, it's a little bit more obvious. All we have to do is take that 14 degrees and add it to 180. And we have our direction angle. And just a little note, it's basically, -14 tells you a direction. It's telling you, 14 degrees. It's telling you 14 degrees south of west. And what 194 is telling you is that if you're pointed in the direction of 0, then you should basically turn around and curve a little bit more. The other trick is thinking about the fact that this is actually north, which is considered 0 on a compass when you're looking at it in real life. Craziness. That's all about bearing and stuff like that. And that's a wrap. Hey, thanks for learning with me, and I hope you find success with vectors. Bye now.